power to a power. And so if you took 5 cubed all to the power of 5, remember what exponents are telling you. It's repeated multiplication. So we're taking this 5 cubed and we're multiplying it by itself 5 different times. So if we want 5 groups of 3 5s, how many total 5s are we going to have? 15. And so to get that number, the easy 5 groups of 3 is just a product or multiplication. So if we take 5 times 3, we get our base of 5 to the 15. Anytime you take a power to a power, you simply multiply their powers. Okay, the final rule is one that I'm not going to discuss a whole lot in this section. I just want to introduce this to you because this is the point where things are going to get confusing, dealing with absolute values. Okay? And you have to be able to think through this. Does the absolute value provide you any additional information that you can't tell without it? Okay, so if you square a base, is there any way that that number can ever be a negative? No, not in the real number system. Okay, what about absolute values? Absolute values guarantee that your number can never be negative. So they're kind of doing the same thing. So when you have absolute value over any even powered exponent, you can take the absolute value outside of it. You could take the absolute value of the term first and then apply the power. And really, you don't even need the absolute value because it doesn't give you any additional information. Okay, being able to distinguish when an absolute value can or does not give you additional information is the difference or the concept in this chapter or section or couple sections that is the thing that's the most difficult for students. And so you're not going to do a whole lot right now. You are going to in this chapter, however. First is just the straight power to a power. When you take a power to a power, you multiply the power. So negative 4 times 3 gives you x to the negative 12. So you can either leave it in that form, or you can apply the properties of a negative power, move your base x to the denominator, and change its sign. In the second is more similar to what you're probably going to see with all of these when you simplify. You have this product, a power of a product, as well as power to a power built into that. So this power of 2 is going to apply to every individual base factor. So it's going to apply to the 5, going to apply to the x cubed. So when you take a power to a power, you multiply powers. It's also going to apply to the base y to the 5th, power to a power. So when you simplify 25, 3 times 2 is 6, 5 times 2 is 10, and you get your simplified form. Okay. Part C is the exact same. This power of negative 4 is going to apply to the 4, the base x, base y, and base z. So 4 to the negative 4, x to the negative 5 times negative 4, y to the negative 6 times negative 4, and z squared times negative 4. So when you look at these, you can simplify what you have. The 4 to the 4th is one that you do not need to evaluate. So you can just leave it as it is. Okay. The fact that it has a negative power means we can move that into the denominator, creating a fraction. Okay. We have x to the negative 5 times negative 4 is positive 20, so that can stay in the numerator. For the y's, negative 6 times negative 4 is positive 24. That can stay in the numerator. And the z, 2 times a negative 4 is a negative 8. So we're going to take our z, move it to the denominator, change its sign to a positive 8, and that would be our simplified form. If you evaluated 4 to the 4th, that would be okay as well, but you don't necessarily need to.